find the missing lengths of sides, to find the missing lengths of sides in similar figures and to find the missing measures of angles, you have to know that similar figures are figures that are the same shape but not the same size, but they're proportionate to one another. And you also have to know about corresponding sides and corresponding angles. Corresponding sides are sides of similar figures that match and are proportionate to each other. Corresponding angles are angles of similar figures that match and they are congruent. So in number 1, the directions are asking us to find the missing length x and the measure of angle g. We'll actually start with the angle measure. Angle G is on the bottom right-hand side of the small triangle, and that matches with angle C of the large triangle. So angle G would measure the same measure as angle C. Since angle C is 37 degrees, then angle G is 37 degrees. Again, the matching angles, corresponding angles, have the same angle measure. Since angle G corresponds with angle C, and angle C is 37 degrees, that makes angle G 37 degrees. Now to find the missing length of x, we have to set up a proportion, since corresponding sides are proportionate to each other. So here we're comparing the small triangle to the big triangle. Like I said in class, it doesn't matter what words you use here to tell you the difference between one triangle and the other, as long as you know which one's which so that you put the correct numbers in the correct places in the proportion. If we start with side x, it's on the small triangle, and it matches or corresponds with the 12 on the bottom of the big triangle. We have 2 other lengths of sides on the small triangle, so we can choose either the 5 or the 3. It doesn't matter which we choose. If I choose 5 on the small triangle, I have to pick its match or its corresponding side on the big triangle, which is 15. And if I multiply 15 times x, I get 15x. And 5 times 12 is 60. Then I solve this equation by dividing both sides by 15. And x equals 4. So that means the length of side x is 4 centimeters. If we're working a problem like number 2, it's the same idea, except this time we don't have the figures drawn for us, so we can go ahead and draw them. The question's asking us what's the width of the large photo, yes. Pat's school picture came in 2 different sizes that were proportionate to one another. The smaller size is given to us in the book. It's 1 5/10 inches by 2 inches. The problem is telling us that the large picture has a length of 10 inches and it's asking us for the width. So sometimes drawing the pictures and the diagrams to help you solve these can help. Once again, we have to set up a proportion of what we're comparing. In this problem, we're comparing the small picture to the big picture. The small picture has a width of 1 1/2 inches matched to an unknown width of the big picture. The small picture has a length of 2 inches compared to a length of 10 inches on the large picture. To solve the proportion, we just cross multiply. W times 2 is 2W. 1 5/10 times 10 is 15. We divide both sides by 2, and the width would be 7 1/2 inches. We're going to use the same idea to help us in the direct measurement lesson. For number 1, they want us to use similar triangles to find the height of the flagpole. Here we're comparing heights to shadows. The height of the actual flagpole is what is unknown compared to its shadow of 30 feet. And the flagpole is being compared to a person with a height of 5 feet and a shadow of 10 feet. So we got these numbers from the diagram. The height of the flagpole compared to its shadow, the height of the person compared to its shadow. And then we cross multiply. H times 10 is 10H, 5 times 30 is 150. So we divide both sides by 10, and that means the flagpole has a height of 15 feet. With number 2, we don't have a picture. We can either draw a diagram or just rely on our proportion, height to shadow. In the problem, they're asking how tall is the tree, and they're telling us that the tree casts a shadow that's 26 feet long. They're asking us for its height. The tree is being compared to a yardstick. The yardstick has a shadow that's 4 feet long. So for shadow, we have to put 4 feet. And a yardstick is 3 feet long. So that information isn't given, but that's just a piece of information that you're expected to know, that there are 3 feet in a yard. When you cross multiply, h times 4 is 4h. And then you multiply 3 times 26, which is 78. Divide both sides by 4. And when you do that, you don't come out with an exact answer, so you have 2 choices. You can either make a fraction, or you can make a decimal out of your answer. So when you divide, you can either get 19 5/10 feet, or you can make your remainder into a fraction and get 19 1/2 feet. Either one would be appropriate.